Welcome back, student. In this video, we are going to discuss the next method, Vogel's approximation method, to find the initial basic feasible solution. For the given transportation problem. In the previous video, we discussed about the least cost method. Here we are going to discuss about Vogel's approximation method. How we are going to use this method? What is the steps we are going to follow in this? First, in step 1, I am going to find the difference between two least cost row wise and column wise. I am going to find the difference between the least cost row wise and column wise. Then in step 2, I am going to find, or I am going to select the maximum difference. I am going to select the maximum difference. In step 3, we are going to select the least cost on the corresponding row or column. Maybe on the column or on the row. And we are going to use the last idea. We are going to allot the minimum of availability and requirement. We are going to proceed, or we are going to continue until all the values are allocated. What is this, teacher? See, first what I am going to do now, if we take this example, find the IDFS for the following transportation problem using Vogel's approximation method. I have taken the same problem what we discussed in the previous class. We are having 3 origins and 4 destinations. We are having 3 origins and we are having 4 destinations. The corresponding availabilities are given and the requirements are given. When we check the availability and requirement, the total is 950 equal. This is a balanced transportation problem. First, what I am going to do now, I am going to find the difference. Between the least cost. I am going to find the difference between row wise and column wise. I am going to find the difference between row wise and column wise. I am going to check the least two numbers here, 11, 16. I am going to take the least two cost, 11 and 16. The difference is 5. I am going to take the next two numbers, 13, 18. Again, the difference is 5. I am going to check 14, 13 because I am not taking first row, 2 rows or column. We are checking the least value. When I check here 11, 16, these two numbers are the least value, the difference is 5. Next I am going to check here 13, 18. So the difference is 5. When I check here I am having the least cost here 14, 13. So the difference is 1. When I check here 10, 12, the difference is 1. 10, 12, the the difference is 1. In the same idea, I am going to find the difference between the cost, least cost in column wise. I am going to check here the least number 11, 13. The least number 11, 13. So the differences. I am going to check in the next one here 10, 14. Isn't it? 10, 14. So the difference is. When I come to this row, this is 12, 13. So the difference is. Now in step 2, we are going to select the maximum difference. We are going to select the maximum difference. I am going to check here. This is 2, 4, 1, 1, 1, 5, 5. I am having 2, 5. I am going to select the maximum value. Any 1, 5. I am going to select any 1, 5. I am going to select this 5 as we are having 11 as the least value. I am going to select this 5 as we are having 11 as the least value. Now I am going to check the minimum of the availability and the requirement. The minimum of the availability and the requirement. When I check here I am having 250. The availability is 250. My requirement is 200. So I am going to allot 200 to this cell. I am going to allot 200 to this cell. So here I have allotted all the values. So here there is no balance. From here we will be having 50 as the balance. We are going to have 50 as the balance. Now we are going to continue this. We are going to continue this until we allocate all the availability and resources. We are going to proceed the same thing until we allot all the values. So just I am cleaning the board. See now what I am going to do now, here when we check, as we have allotted the value, the whole value, here this is cancelled, isn't it? There is no, this thing, we are not going to consider this. Next I am going to find the difference. We are going to find the difference. So here already we have completed, there is no difference. I am going to check the next one. Here I am going to check what is the two small numbers. Again 13, 18. The difference is 5. Here 14, 13. The difference is 1. 10, 12. The difference is 2. Sorry, the difference is 2. In the same way, we are going to check the column wise here. 13, 14. The difference is 1. 10, 14. The difference is 2. Sorry, 4. 10, 14. The difference is 4. 12, 13. The difference is 1. I am going to check the maximum difference. Again, 5 is the maximum difference. I am going to check for the least value. I am going to check for the least value. What is the least value in this particular one? 13 is the least value. So I am going to allocate to the value of 13. Now I am going to check the minimum. Here I am having 225. Here I am having 50. I am having 50. So what is the minimum value? 50 is the minimum value. So I am going to allot all the 50 here so that this will get cancelled. When I allot 50, 225 minus 50, I will be having the remaining requirement of 175. We will have the remaining requirement of 175. Now when we are moving to the next difference 3, here there will be no difference because already we have allotted all the values. Here there will be no difference. Now I am going to check here. This is 18, 24. The difference is 6. 18, 24. The difference is 6. 14, 13. The difference is 1. 10, 12. The difference is 2. In the same idea, I am going to find here the small values. 10 and 14. The difference is 4. 12, 13. The difference is 1. Now I am going to check the maximum value. Again we are getting the maximum value 6 in this place. I am going to check the least value. What is the least value in this particular place? 18 is the least value. I am going to check how much I can check here. 175. This is 300. So the small value is 175. So this will become 0. This will become. Here what will be the remaining value? The availability. So 175, 300. So this is 125. This will be 125. Next, we are going to find the next difference, D4. Like this, we are going to keep finding the difference until we finish all the allocation. Here there will be. But when we come here, we will not have the difference for this two places, isn't it? Because already this is filled and this is also filled. Now I am going to check the difference here. 14, 13, the difference is 1. 10, 12, the difference is 2. I am going to check here. Here the difference is 4. Here the difference is 1. So we are going to take the maximum value. The maximum value is 4. Here I am going to check what is the small number. Here what is the small number here? 10 is the small number. What is the small number here? 10 is the small number. So I am going to check. This is 250, 125. That means I can allot 125 here. I can allot 125 here. So this will become 0. This will become 0. Here we will be having the balance of 125. We will be having the balance of 125. That means there is no allocation. Now we are having lost two values. So there is no need to find the difference. I can add the value as it is. So this is 275 and this is 125. So this is 125, 125. So for using Vogel's approximation method, we are going to find the difference between the least values column wise and row wise. From this, we are going to select the maximum number. And from the maximum number, we are going to take the smallest cost, the least cost. From the maximum number, we are going to take the least cost. And we are going to make the allocation. Then we will proceed the same idea until all the values are allotted. Now we are going to find the IBFS, initial basic feasible solution. I am going to take the corresponding value and I am going to multiply. This is 200 multiply 11. The next one, 50 multiply 13. The next one, 175 multiply 18. The next one, 125 multiply 10. The next one, 275 multiply 13. And 125 multiply 12. We are going to simplify the values. So 200 multiply 11, this is 200, 2200, 50, 650. So 175 into 18. 3150. Plus this is 125 into 10, 1250. 275 into 13. 275 into 13. This is 3575. 125 into 12. 4 is 100. 400. 4000. So I am going to find the total. So we are having 200 into 11, 2200, 500 into 13, 650, 175 into 18, 3150, 125 into 10, 1250, 275 into 13, 3575, 125 into 12, 1500. There was a multiplication error, 125. So I am going to find the total. This is 12325. 2, 5. This is 1, 2, 3, 2, 5. This is how we are going to find the IBFS, initial basic feasible solution, using Vogel's approximation.